Well, I think the primary reason was there was a teacher at my high school that had attended UCSB in the very early years, even before it went to its present location. He knew of it, and he spoke very highly of the quality of education I would get there. Engineering-wise, it was a younger program than some of the other schools, but he knew the educators. He knew their dedication to teaching, and he said for an undergraduate education, you'll get as good or better there, and probably more professor attention than some of the other campuses. There are a lot of them. I certainly remember the classes and all the things I was taught. I remember that pretty well, and the labs, the long labs. I remember the beautiful campus and the setting, and where I lived, and the people, especially the people. Roommates I've kept for friends for life. I see them on a fairly regular basis. And my girlfriend that turned into my wife. I was very interested in radio and communications. If you were a nerd back then, you were playing around with different forms of communication, such as amateur radio, which was very big back then. And playing around with computers was pretty unheard of. So we're talking high school in the late 1960s. So you form your impressions then, and I was good in math and science, and so I was encouraged by the teachers there to look at electrical engineering. On the technical side of my career, which is the longest arm of my career, probably developing the world's first high-performance CMOS operational amplifier. That was a turning point not only for the company but also for the industry. So that was a big deal. That was back in '83. And then on the business side of my career, it's founding and growing the power management business unit, which I grew into the biggest business unit in the company, and today represents over half our revenue. I've always been challenged. I've been given the opportunity to continuously learn, not been boxed in by a rigid job description, been allowed to move along a technical path from individual contributor to technical manager, and then allowed to move on the business side and sort of be an entrepreneur within the corporate framework, and then return to the technical side when I was named a fellow and chief technology officer in 2000. So being able to, I guess, continuously learn and be challenged and rewarded for it, that's what kept me here. I guess the very first thing is make sure that engineering is something that you enter in for all the right motivations. It really should be something that you derive energy from, that you're passionate about, that you'd be willing to really stick to. So it's got to have some intrinsic connection, I think, with you. As for courses, when you're an undergrad, be broad. Even if you have a pretty good idea of what you want to specialize in, be broad. This is your opportunity to sample a lot of things and be grounded. Learn how to learn, because it's going to be a continuous process throughout your career. If you're in technology, you better reinvent yourself and fill your mind with new knowledge on a continuous basis. So learn how to learn and to appreciate that. And then as you get further along in your education, as we talked about before, look for internship opportunities to round yourself, to sample the working world. Oftentimes people have a narrow view of what their job may be like, and then when they get out there and look at a corporation and all the different paths you can take in a corporation, then it gives you a lot more to think about what you might want to do. You can look at a small company, you look at a large company, they all have pros and cons. So find your passion. Stay, I guess, uncommitted for a while, and then go for it. Then really go for it. Yeah, that's been on and off depending upon what our area of interest is and what the area of focus is. More recently, there's been a fair amount of discussion going on about collaborations in the area of 3-5 materials, particularly gallium nitride transistors for applications in power, which is a new application for GaN as opposed to the traditional high-frequency application, power amplifiers for communication. We're talking power conversion, energy efficiency, that sort of thing. So we've had discussions with professors, Denbars, with Mishra, with Rodwell, and others about possible collaborations. Well, certainly the fundamental grounding you get in your undergraduate is important. So that has helped me in lots of ways. I've saved a lot of my course notes. So there's that. Then there's a specialization. I specialized in semiconductor devices and circuits in my final year, and that became my career. So that was extremely instrumental in terms of making me attractive to companies and allowing me to hit the ground running, when I came here. My message to the students: I think engineering has a bright future. You should not only consider it to be your lifelong profession, you should be encouraging your children to do the same. And if you're reading headlines about jobs going overseas, don't let that dissuade you. This is still the center of R&D, and there's lots of interesting work you can do. You can solve some of the world's major societal problems or make a major down payment on them through your technical knowledge. So look for things that will really motivate you. We've got some big societal problems, environmental problems, and science is one of the big ways forward. So your contribution to that is very welcome.